Alright, so here we're going to talk about the reaction that's kind of companion to the E2 reaction, the E1. Now, I can't talk about the E1 reaction without also talking about SM1 because they always appear together. Now, some particular details about the E1 reaction as compared to SM1. You'll find that some things about E1 and SM1 are literally exactly the same. In fact, half of each mechanism is exactly the same thing. If I was to ask you what's the first part that always happens in an SM1 reaction, hopefully you'd say, knowing it's two steps, you'd say the first step is loss of the leaving group. In other words, like this. Now the fact is, in an E1 reaction, the first step is exactly the same thing. So the loss of the leaving group is the first thing that happens in both. So therefore the leaving group coming off doesn't actually give you any way of differentiating between the two. So let me just run through the mechanism here just so we can all see what's happening. And I'm going to draw out the intermediate. So we get out our carbocation here, our secondary carbocation. So we lose all that stereochemistry. That was sp3, this is sp2. So if you remember in the SM1 reaction, well, what happens next is that the nucleophile comes in, attacks here, and you get your product. And if you remember, we had the situation where the stereochemistry of the product was actually 2 enantiomers because the nucleophile could come in from either side. And that's exactly what would happen here. But if you have a compound here that's a weak nucleophile and a weak base, all right. So in the previous video about the E2 and SN2 reactions, I talked to you about how things like CH3O- was a strong base and a strong nucleophile because it's negatively charged and it's small. So it turns out that for exactly the same reason, a neutral nucleophile that you know as a weak nucleophile is exactly also a weak base. All right? Just as OH- would be classified as a strong nucleophile and strong base, and H2O will be classified as a weak nucleophile and weak base. So when we have something like methanol here, this is really the key to telling us what's happening, because this substrate is secondary. From what you've seen before, you know that in an E2 reaction that's preferred by tertiary halides and not preferred by primary halides. So for secondary it means it could go either way. So what that means is, if the methanol here is a weak nucleophile and a weak base, and this secondary substrate doesn't really prefer one or the other, then what happens is both happen. All right, both mechanisms happen. So what we need to look at is, can we draw out the products of each of our reactions? So I'm going to do what I did first, and I'm going to list the E1 products first and then the SM1 products afterwards. All right. So for the elimination reaction product, actually, you know what, let's just look at the substitution first. For the substitution product, this guy just goes right in here and gives us our 2 enantiomeric products. And I'm just going to show the products after deprotonation. So what we get here would be something that looks like this, and then this guy here, and then this, which would be the enantiomer of that, this. Okay? So these would be my 2 enantiomeric products that we'd know what to expect from an SM1 reaction, because we've seen that before. So for the E1 reaction though, let's just take a minute to think about that. Based on watching my previous video, you'll know that that's the alpha carbon, and I got 2 beta carbons here. These 2 carbons are different. That's beta 1, we'll call that beta 2. So there's a hydrogen on the beta 1 carbon, a hydrogen on the beta 2. From what you guys have seen before, which hydrogen gets removed? Is it the one from beta 1 or from beta 2? Well, from what you've seen before, the Zaitsev rule still applies. Whether it's E1 or E2, you're always looking to form the most stable alkene product, so that nucleophile grabs that hydrogen, breaks that bond, and in an E2 reaction the leaving group would then come off, but in an E1 reaction it's already come off. So the product here is this. So we'll get one elimination product, two substitution products, providing there was stereochemistry to begin with. If there was no stereochemistry, then you would only show one. But the point is that both mechanisms occur. So both the elimination and substitution mechanisms occur when you've got a secondary alkyl halide. Now let's think about it for tertiary. Now you know that exactly the same thing applies for a tertiary alkyl halide. The first step is always loss of the leaving group. It's just faster here than it is here. So if we got a mixture of E1 and SN1 products here, we had a intermediate carbocation. We're going to have the intermediate carbocation here as well. It's just going to be tertiary versus secondary. Exactly the same principle applies here as it does here. So if we have something that's a weak nucleophile and a weak base, if there was no preference for which one happens here, there's also no preference for which one happens here. In other words, we again get both sets of products. I haven't shown any stereochemistry in this product though, so that's going to make drawing out our substitution products a bit easier. But let's look at the elimination product. Again, this is our alpha carbon. We have the beta carbons here. We'll call these beta 1 because they're the same, and this one is beta 2. And of course the hydrogen comes off the more substituted carbon, which of course is this one. So that hydrogen goes there, kicks that up there, and we get our tri-substituted alkene E1 reaction product. For the substitution, again, I'll show the product that is after deprotonation. By the way, this is not a negative, that's supposed to be a lone pair. All we're going to show in the product is the chlorine having come off and the OCH3 in its place. So what really matters here is that the E1 reaction never occurs on its own. It always occurs along with substitution. For secondary alkyl halides with a weak nucleophile and base, both mechanisms occur. For a tertiary alkyl halide with a weak nucleophile and weak base, both mechanisms occur. For primary alkyl halides, the stability of the alkene is such that you really don't see any E1-SN1 reactions occurring. So only for secondary and tertiary alkyl halides. So that is the E1 and at the same time the SN1 reaction.